Now, units can be defined as the entities that helps to carry out measurements, and that can be of any kind. As an example, uh, length measurement or weight of any element. So this type of entity, if you want to measure, so that can be measured in a particular unit. So all type of measurements are carried out with such kind of some logical units, and also that can be some precision. So that's why it is called precise units is required to measure the entity. Now in units there are two type of units available. Number one, that is known as fundamental units. Now fundamental units are those type of units that are used for measuring quantities, and that are not dependent on any type of unit for its existence. And if we consider a second type of unit, that is a derived unit. So derived units are generally defined as the units that is derived from the fundamental units, and are dependent on the other units. And in other words, if we say that these units are dependent by mechanical equations in terms of other previously defined fundamental units. Now if we talk about system of units, system of units, so we have basically a four type of systems available up till now. So we discuss one by one. So first one we take a FPS unit system. So in this system the fundamental units of length, mass and the time is foot, pound and second. Furthermore, after that a CGS system is used. So in this system the fundamental units of length is centimeter, then the of mass is gram and the time is second. Furthermore, if we go, so that is another system that is known as MKS system. So in that fundamental units of length is meter, then the fundamental unit of mass is kilogram, and the fundamental unit of time is second. Now these three unit systems are generally used, but there is a variation available in a fundamental units. So one more system that is derived or established in a international form, so that is known as a system international, SI system of units. Now SI system of units came in existence in October 1960, and it is officially recognized and adopted by all the countries in the world. Its actual use varies from country to country. Now if we say the number of methods available in system of units, so if we say the USA, that they are using generally a foot, pound and second system, and in India even also some measurements are noted in foods system. Now due to that there is a requirement to become a make a one platform, and there will be a SI unit system that is becoming slowly more popular amongst the intellectuals. Now the system SI unit system it based on seven basic units or principal units. The category and name if we define, or I can say the we make a one table of that category of the fundamental unit, or we can say the unit of the SI system. So here let we make, so we make a title of category, then the name and the abbreviation. Now first we consider uh, length. So the name of length or the unit name of length that is meter, and the symbol or the abbreviation of that is small m. If we take another entity that is a mass, so that is in kilogram and kg, small k and small g. Number 3 is time, that is in second, as. Number 4 we consider electric current, so that is in ampere and symbol is A. Number 5 that is temperature, that is in Kelvin and symbol is capital K. Then after number 6 that is amount of substance, that is in mole and symbol is small mol. Now last one that is number 7, that is luminous intensity. Candela, small c d. So these are the abbreviation and category and its unit name that is we generally mention in the SI units. So this is all about system of units available, and the SI unit is system that I already said that is widely accepted and widely used amongst the researchers, amongst the intellectuals, and for the education purpose also. Now furthermore if we go with one more important point, so that is definitions of fundamental units. So here we have a number of fundamental units. So in that, if we take a definition of one by one, so I just tell you that what is the fundamental unit definition. So first we take a meter, and abbreviation of that is small m. So meter is the basic unit of length and is defined as the distance that actually travels by light in a vacuum in 1 by 2 into, and it is the distance that travels in a vacuum, and actually that is with 1 by 3 into 10 raised to 8 part of second, so that we call a meter. Second is a kilogram. So now it is the basic unit of mass and is defined as the mass of international prototype in the form of a platinum iridium cylinder that is capped in Sivers in France. Furthermore, second. So second is the basic unit of time, and that everybody knows, and that is similar in all kind of system, and it is defined as the length of the time for 9 approximately 9 into 10 raised to 9 periods of the vibration of the calcium 133 atom. So for that particular time period, whatever the vibrations available, that is called time, or we can say the second. Now ampere is the basic unit of electrical current and is the current which produces force between the two parallel wires that are 1 meter apart, and that is the measure in a vacuum. Next is the Kelvin. It is the basic unit of temperature and is defined as the 1273.6 1 by 273.6 part of the thermodynamic temperature of the triple point of water. Next is a mole, and it is the basic unit of substance and is defined as the amount of substance that contains as the many elementary units as there are atoms in 0.012 kg of carbon 12. Last one is the candela. So it is the basic unit of luminous intensity and is defined as the intensity of source of light of a specified frequency which gives a specified amount of power in a given direction. So this is a definition and uh, detail about fundamental units. Now if we talk about derived units. So now in derived units, various units are generally derived from fundamental units to cater the need of the field. Now we take one by one. So in that, first one is Newton, and the symbol is a capital N. So that everybody knows that Newton, right? It is the SI unit of force particularly. So and it is generally defined as the force required to give a mass of 1 kilogram and acceleration of 1 meter per second, and it is basically on the name of English mathematician and physicist Sir Isaac Newton. Second we take Joule. and the symbol is again a capital J, and this is a unit of work or energy, and it is defined as the amount of work done when an applied force of 1 newton moves through a distance of 1 meter in the direction of the force. And it is also on the name after the English physicist James Prescott Joule. Third one, that is Pascal, capital P and small a. It is a unit of pressure, and it is defined as the pressure generated by a force of 1 Newton acting on the area of 1 square meter. It is after the name of French mathematician, physicist, and a philosopher Pascal. After that, we have a fourth one, that is Watt, and again symbol is capital W. It is a SI unit of power and is defined as the rate of change of 1 joule work done per second. It is also named after the Scottish engineer James Watt. Now, after the getting the information about the fundamental units and the derived units, now it is generally the units fixed with some dimension, but it also required to describe the smaller measurements or the larger measurements. So to derive that, we have also studied a prefix. So prefixes of SI system that required to make a smaller unit or a larger unit. If we take an example that generally a distance covered by a man, and that could be measured in a meter or a kilometer, right? So distance that is measured in meter or a kilometer. Now we can say that kilometer, that is nothing but a 1000 meter. Okay, 1 kilometer, that you can write in 1000 meter. But if you want to mention that kilometer in a millimeter unit, so that will be a big entity. So 1000 again 000 mm. Now see that it is very much difficult to mention like this and also looks very odd. So similarly, we have to know that the prefixes that we apply, and in terms of that basic unit and the prefixes we write down, so that will be a proper conversion of that particular unit. So in that we have a long list available. So now we are just looking to that numbers. So now you just look at to that for a while, so you understand that there are 16 type of prefixes available with its symbol, its meaning, and the exponential notations. Now next point is convention of uses in the SI system. Now generally following rules are adopted or followed to ensure the correct uses of the SI system. So we take a one by one. So number one is any unit may have only one prefix. So one prefix is allowed for any one unit. For example, if we take a 1000, oh, this is 1000 and 000 meter, and that shall not be written as a 1 kilometer, right? It is not a proper word to use or a proper prefixes to use, because one prefix is already available, so we cannot again apply a second prefixes. So this is not a proper pattern. So you can write 1000 kilometer, or you can write 1 megameter. So these two are allowed. Now second, if we take, that is prefixes that makes a unit bigger are written in a capital letter. So use capital letter, right, for prefix. This is a second rule. So that letters we generally take as a mega, giga, tera, etc. Right? So and prefixes that make a unit smaller. So this is a capital letter that is used to define prefixes that will make a unit bigger. In another way, we can use a prefixes letter or a small letter like this when the unit make smaller. So out of that, there is a one exceptions to this are the kilo. So in that, that is written in this form with a small k letter. Now to avoid a confusion between Kelvin K, so because that if we take Kelvin, so we generally use a capital K, and also we have another type of units, that is hecto. So here we use a small h, and also we have a deca, so we use a da. So these are the exceptions. So kilo is one type of exceptions that is written in this small letter, even though it will make a unit bigger. So to avoid the confusion between the Kelvin, hecto, deca, etc. Now third one, so the units are written in abbreviated form and are never pluralized. So can written in abbreviated form and never pluralized. For example, if you take 5 meter is symbolized 5 meters is symbolized, right? As what? 5 and a small m, and that is not as 5 and meters. No, this is not a proper. Okay, so that is abbreviated but not a or never pluralized. Furthermore, if we take a number 4, so an abbreviation is never followed by a full stop. So no use of full stop. So whenever you write down form of units like a T, so do not put a full stop. This is wrong. If you write down T, that is okay. So never use this full stop. Again, and then Pascal, that is PA, and meter, that is small m, etc. This is the proper way of writing. Never use the full stop after the units. Now after that, there is a important thing is a unit and its conversion. So conversion is very much helpful in all ways, and day by day calculation and the provision of the units. So one must have a knowledge about the unit and its conversion, so they can convert one unit to the another unit, and vice versa with some uh, provision of factors, so that can be very much easy to understand, and that can be very much easy to convert that particular unit to another unit, and that is also very much helpful to understand between the different type of system of units. So now this is all about convention of uses in the SI system.